go. All right, so we're on page number 311, 311. We're on section 9.2, solving by extracting roots. All right, so we're going to do this lesson. This is for Tuesday, May the 5th. I hope you had a good May the 4th. Anyways, then today's May the 5th. For tomorrow, there should be a quiz that's being sent home, which you're to do. It's over sections 9.1 to 9.2. Try to review for that before this is over. And then on Friday, we'll have another video, which should be over section 9.3. All right, so let's look at this page 311. Now, yesterday, we did the solving quadratic equations by using that zero property. All right, so we factored it down, and then we ended up normally, sorry, I just got chalk on my hand, I hate it. Did you know I hate chalk? And then we used the zero property, so x minus 3 equals 0, x plus 6 equals 0, so then we'd solve it 3 and negative 6. Now we're going to do page 311, solving by extracting roots. Here's my lame attempt at drawing roots. But solving by extracting roots. All right, so look at that, page 311. It says in the previous section, B, remember the second number, is any real number. However, a special situation occurs if b equals 0. In the standard form of a quadratic equation, the equation takes the form of ax squared plus c equals 0. It is called a pure quadratic. All right? So what is a pure quadratic? It's also called an incomplete quadratic. But basically what it means is if you have, like we had this as one of the last problems you did yesterday. All right, x squared equals 16. We bring that over, we have x squared minus 16 equals 0. That is a pure quadratic or an incomplete quadratic. And what that means is this, there's no middle term. All right, the middle term's gone because a quadratic normal state would be x squared, whatever number, plus whatever number x, plus whatever number equals 0. The a, b, and c represent numbers, so it can be whatever they want to be. So here we don't have that middle term. So the b is 0, which eliminates it. So how do you solve these? Well, you do that by extracting the square root. Now, this one's simple, all right? We actually did it yesterday. We know that that would be x plus 4, x minus 4. So the answer is x equals a positive negative 4. Because x plus 4 equals 0 makes the negative 4. X minus 4 equals 0, you go to positive 4. What we're going to show you now, though, is that you can take this and extract the square root, all right, by, if it started in this case, you can leave it there, all right? Or if it starts this way, you're going to bring that back over. Not difficult. Sounds weird, but it's not. All right, so let's go back to this position right here. All right, x squared equals 16, all right? So the way to solve that, if you just have a pure quadratic equation, no middle term, then you can find the square root of that. Square root of x squared is x. Square root of this. Square root of 16 is 4. And we don't know if it's positive or negative. Same answer, all right? So it's actually simple. The only problem with this, they compound it and makes it more challenging. That's a good word. All right, so again, so if they ever start out, in this case, with a pure quadratic, such as x squared minus, let's do 9, all right? X squared minus 9 that equals 0, move that 9 over, you want to isolate the square, all right? So x squared equals 9, because we added 9, square root, and that is positive or negative 3. Right? Because you don't know. Negative 3 times negative 3 is 9, and a positive 3 times positive 3 is 9. So you're not sure which one it is. So positive, negative 3. That's all we're doing in a nutshell. Of course, it's algebra, and it's a Becca, so we're going to get a little harder. But, all right, if you want to look over to the next page, 312. Says this, if a doesn't equal 1, now remember that's your first term, like we had like x squared minus 16 equals 0. If that x squared is not 1, all right, then if a doesn't equal 1 in a pure quadratic, be sure to divide both sides of the equation to isolate the squared quantity. Now, what does that mean? Here's the example. We have 2x squared equals 50. All right? I can't find the square root until I just need just the square by itself. So I have to get rid of this 2 by dividing by 2, divided by 2. Now I have x squared equals 50 divided by 2 is 25. Find that square root. What I do to that side, do to that side. X equals the square root of 25 is positive negative 5. All right, that's all that paragraph was saying. Sometimes it's going to end up in fractions, and that's okay too. All right, fractions are your friends. Remember that. Such as 6x squared equals 5. 6x squared equals 5. I need to isolate this, so I'm going to divide by 6, divide by 6. X squared equals 5 over 6. Watch closely. Remember everything we learned. All right, I got to get the square root. That eliminates that, gives me with this x. But then I have to find the square root of 5 6. Remember how to do the square roots of fractions? No? Oh. Yes? Whatever that applied to. Take it. All right, remember what you have to do. You have to do the square root of 5 and the square root of 6. We cannot have a denominator having a radical sign. Remember that rule? Keep flashing it on the screen. You can't have that. So to get rid of it, the only way to get rid of that is I'm going to have to multiply it by a square root of 6. But what I do to one, I have to do to the other. So now what's the square root of 5 times the square root of 6? The square root of 30. The square root of 6 times the square root of 6 is the square root of 36. What is the square root of 36? 6 over the square root of 30. You always need to check, can I break that down any further? My options for 30 are 1 times 30, 2 times 15, 3 times 10, 4, 5 times 6. Are any of these factors a perfect square root? No. All right, none of them. You can multiply something by itself to get any of these. So that's the answer. All right, so the answer to that one would be x equals positive negative square root of 30 over 6. So, like I said, makes it a little bit more challenging, but it's not too bad. All right, page 312. At the bottom, all right, they give us another option, another ways that these can be presented to you, is 2x minus 1, the whole thing squared, equals 16. All right, so I know that means 2x minus 1 times 2x minus 1. So I can get rid of that by square rooting it. The square root of 2x minus 1 times 2x minus 1 is 2x minus 1. But what I did there, I got to go over here. So what's the square root of 16? 4. All right, so we have 2x minus 1 equals, and we did the square root of 16. And the square root of 16 is positive negative 4. Now watch closely on this. Now I can't just put 4 because it could be negative. Now I need to get rid of this 1 by adding 1, which leaves me with 2x equals, I add 1. Now it's either plus, minus, 4. Because it depends. I have to get rid of the 2 dividing by 2, dividing by 2. So here's the answer. X equals 1 positive negative 4 over 2. Now you can leave it at that. All right, and which is great, actually, the way they want it. If you wanted to go back and check it, it would mean these two answers. X equals either 1 plus 4 over 2 or x equals 1 minus 4 over 2. But in any case, you're going to get the right answer if you plug them in. All right, so you may have to go back and rewind that one again because I actually had to stop and redo that one too. But I get to edit things. You don't. All right, so again, I had the 2x minus 1, the whole thing squared equals 16. I had to square root that to get 2x minus 1, but what I had to do there, I had to do over here. So that leaves me with the positive negative 4. That has to stay positive negative 4. Then I add 1, so then I have 1 positive negative 4 divided by 2 over 2. All right, so that is that answer. All right. They give us one more example. Let's do that one too. On page 313, 9.2D. All right. I'm doing my best to keep these at 15 minutes. All right, so, but sometimes I can't. So the last example is x minus 5, the whole thing squared, minus 32 equals 0, correct? All right. So I need to, again, isolate the square. So I'm going to move this 32 over here. So I have x minus 5, the whole thing squared, equals, I add 32, so positive 32. To get rid of the square, I've got to square root it. What I do there, I have to do over here. So now I have x minus 5 equals, now this 32, there's no perfect square root, so I'm going to write out my factors and see if I have a perfect square root in there. So my options are 1 times 32, 2 times 16, 3, 4 times 8. That's it. Are there any perfect square roots? Well, there's a couple. I have 4, but I also have 16. That's the highest, so use your largest one. So x minus 5 equals the square root of 16 times 2. What is the square root of 16 times 2? Square root of 16 is 4. So x minus 5 equals 4 times the square root of 2. Now that's nothing new. We learned that the last 10 days. All right? Now I need to add the 5 to get rid of it. I'm sorry, I forgot something. Ooh. All right, when I did the square root, it's positive, negative. So make sure that's in there. Now I add the 5 to get rid of it. I'm going to write it over here. All right, so it leaves me with x equals 5, because I added the 5, positive, negative 4 square root of 2. All right, and that would be the answer to that one. All right? Let's get down there and do some of these. I'm on the bottom of page 313. It goes over to the next page on page 314. I'm not going to have you do all those, so don't, panic on me, all right? So, why don't I want to do those? Why am I not going to assign all those? Is it because you've had enough work? No. Is it because that I don't want you to have to work hard? No. Is it because you already have the concept and you don't need any more help? No. Why am I not having you do all of them? Because I don't want to grade them. All right, so here we go. All right, page 313. You have x squared equals 36. All right, so I got to find the square root to give me just x. Find the square root. Square root of 36 is either a positive, negative 6, and we're done with that one. All right, let's skip on down. Let's do number, I'm just randomly picking them here. Let's do number 5. X squared equals 28. X squared equals 28. Square root, square root. I left with the x. I know it's going to be positive, negative. 28 doesn't have a perfect square root, so I'm going to write my factors down and look for the largest perfect square root, which would be 1 times 28, 2 times 14, 7 times 4. Right? The largest one of those that is a perfect square root is the 4, actually. So it's positive, negative square root of 4 times 7. What is the square root of 4? 2. Positive, negative 2. Square root of 7 is what's left. 14. Let's do 14 real quick. All right, 14 says 5x squared equals 100. All right, I'm going to divide by 5 because I want to isolate the square. So now I have x squared equals 20. Square root, x equals, there's no perfect square root, so I have to find out what it would be. It'd be 1 times 20, 2 times 10, 4 times 5. That's it. That's my largest one. So I have the positive, negative square root of 4 times 5. Square root of 4 is 2. So x equals positive, negative 2, square root of 5. All right, turn the page over. All right, there's some more of these on the back, 15 to 30. All right, numbers 15 to 30. If we do let's just jump down to number 22. No, let's do 20. All right, number 20. I have 8x squared equals 5 minus 2x squared. I want to isolate that square, so I'm going to bring this one over here by adding 2x squared. Adding 2x squared, which gives me 10x squared equals 5. Divide by 10, divide by 10. X squared equals 1/2. You good there? All right, square root it, square root it. I have x equals the square root of 1 over the square root of 2. The square root of 1 is 1 over the square root of 2. I can't have a radical sign as a denominator, so I have to get rid of this by multiplying, always by itself. But what you do there, do at the top. So now I have the square root of 2 over 2 times 2 is the square root of 4. My final answer is going to be x equals the positive negative square root of 2 over the square root of 4 is 2. I don't even know what number it was. All right, 20. Yep. All right, let's do one more. Let's do number 26. 26, and let's do 3x plus 2, the whole thing squared, equals 25. So the way I want to square root it, to get rid of it, square root it. Now I have 3x plus 2 equals positive negative 5, because the square root of 25 is 5. Subtract 2, 3x equals a negative 2, positive negative 5. Alright, then, sorry, my phone's ringing. Let me kill it there. Alright, then I want to get divided by 3. Divided by 3, so x is going to equal negative 2, positive negative 5 divided by 3. Alright, so I guess I should show you this. I looked at their answer. You can go on a little bit farther if you want. I'm going to write it over here. So it equals x negative 2 plus 5 over 3. It also equals x equals negative 2 minus 5 over 3. A negative 2 and a positive 5 would give you a 3 over 3, which equals 1. So x would equal 1 there. Over here, we have x equals negative 7 over 3, which is that answer. So you could take that down further, but I'm fine with it where it is. So. All right, so what I'd like you to do, there's 1 through 30 on page 313 to 314. I want you to do all of the odd ones. All right, so just do the odd ones and call it a day. So page 313, 314, practice 9.2, the odd ones. All right, thanks. Remember, there's a quiz tomorrow. Let me review for that quiz. Oh, yeah, all right. Blur session and then a quiz review. And we're back. All right, so here's your review. I answered my phone too, by the way. Everything's okay. The world is safe. But here's your review for the quiz. All right, so this is going to be Wednesday's assignment is the quiz. It's quiz number 27. And so first thing I have to do, there's 3 questions like we just did. Today's lesson, extracting the square roots. All right, so if you're good there, you're great on 3 of the questions. All right, the first 3 questions on the quiz is from section 9.1. All they want you to do is write it in the quadratic equation form. All right, it even says do not solve. Some of you are going to try to solve it because you always do because you don't read the instructions. I hope I'm wrong, but it says do not solve. All right, so but what it will say is something like this. It'll say, I'm going to make it up here. All right, x squared plus 2x equals 6. So to make it in the quadratic form, you're going to do x squared plus 2x minus 6 equals 0. The key is there's 1, 2, 3 of these, and it equals 0. There might just be 2, but it has to equal 0, and it has to have a square in it. Okay? So you may have to combine some things, like they're going to test you on it a little bit. All right? Like if we have 3x plus 6 equals negative 2x squared plus 3. All right? So I'm going to have to bring this 2x squared over here by adding 2x squared, which gives me 2x squared plus 3x plus 6 equals, I still have that 3. Subtract 3, 2x squared plus 3x plus 3 equals 0. Now it's in the right form. They may not work out because they don't want you to solve them. They're just making sure you know how to do that. And then numbers 4, 5, 6, and 7 on this quiz for tomorrow is solving some of those like we did on 9.1. So you get it in the quadratic equation form, then you're going to use that 0 property to solve it. All right, such as, let me just do one here. All right, let's do x squared plus, let's do 7x equals a negative 12. All right, so first you have to get it in the correct form. Plus 7x plus 12, because we added 12 equals 0. Now it's in the right form. Break it down into 2. It'd be x and x plus 4 times 3 is 12. 4x and 3x is 7x. Then you have to do the 0 property. So my answer is going to be x equals negative 4 and x equals negative 3. All right, so there's 4 of those. So you have to get them in the right form and then solve them. So that's your quiz tomorrow. Okay, so one more lesson for this week. So you had your Monday, Tuesday, quiz on Wednesday, and a final lesson on Friday. See you then, probably in the same outfit because I'm just filming them all on the same day.